Exercise 12.2, problem 15, discussion. Let's read the problem. The probability that A, B and C can solve a problem are 4 by 5, 2 by 3 and 3 by 7 respectively. The probability of the problem being solved by A and B. A and B means A intersection B, okay, is 8 by 15. B and C is B intersection C is 2 by 7. A and C is A intersection C is 12 by 35. The probability of the problem being solved by all three, that is A intersection B intersection C, is 8 by 35. Find the probability that the problem can be solved by at least one of them. This is at least one of them means A, so the either A solving or B solving or C solving or A and B solving or B and C solving or A and C solving or A, B, C solving. So any of these possibilities, that is nothing but probability of A union B union C. So we have a formula for probability of A union B union C. All we need to do is use that formula, and all the values are given here. All we need to do is substitute that values in the formula and simplify it. Okay. So the various probabilities are given. Probability of A, B, C, A intersection B. A and B means it's A intersection B. A and B, okay. B intersection C is B and C, that is 2 by 7. A intersection C is A and C, that is 12 by 35. And all three means A and B and C. All of them can do. So A, probability of A doing and B doing and C doing. All three doing is 8 by 35. We are asked to calculate probability of A union B union C. That is what is the mathematical representation of this statement, at least one of them. Okay, right. Now the formula is probability of A equal to probability of A union B union C is probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability B intersection C minus probability A intersection C plus probability of A intersection B intersection C. Right. So if you check, we know this, we know this, we know this. A and B is also known. This is known, this is known, and this is known. All the values are known. So all we need to do is substitute those values in the RHS and calculate probability of A union B union C. Okay. So substitute the values of probability of A, B, C and probability of A intersection B, probability of B intersection C, probability of A intersection C, and probability of A intersection B intersection C in that formula. Okay, the very big formula which we saw here, right? And calculate the value of probability of A union B and C, which is nothing but the probability of the problem getting solved by at least one of them. Right? So at least one of them means it is mathematically represented as probability of A union B union C. And this is a formula. We have values for all these things. So substitute it and get it. It's a simple, straightforward problem. All you need to know is the formula. If you know this formula, then it is a simple problem. Okay. So let's do the problem. So the various values are given. Probability of A, probability of B, probability of C, etc., etc. And the probability of the problem can be solved by at least one of them is nothing but mathematically, as I was telling you earlier. It is at least one of them means A solving or B solving or C solving or A and B solving or B and C solving. Right? See, A and B solving or B and C solving or A and C solving or A, B, C solving. All these possibilities is represented by probability of A union B union C. And that is given by this big formula. Now all we need to do is we need to substitute all this value. So let's say probability of A union B union C will be equal to probability of A, which is 4 by 5, plus probability of B, which is 2 by 3, plus probability of C, which is 3 by 7, minus probability of A intersection B. Probability of A intersection B is 8 by 15. See, A and B is 8 by 15, right? So 8 by 15 minus probability of B intersection C, that is probability B and C. See, B and C is 2 by 7, right? That's what we have written here, that is minus 2 by 7, minus probability of A intersection C, that is A and C solving, that is 12 by 35. A and C, probability of A intersection C is 12 by 35. That comes over here, plus probability of A intersection B intersection C, that is all three solving, that is given here is 8 by 35, that is probability of A intersection B intersection C, that is 8 by 35. So bring that value here. So all you need to do is now simplify this fractional additions, addition of the fractions, and you'll be able to get the LCM is 105. Okay, so 5 will go 21 times 21 into 484. So do all those calculations. Finally, we end up with 101 divided by 105. So the probability that can be the problem can be solved by at least one of them is 101 by 105. So it's a simple problem. If you know the formula, and if you know to write them mathematically, A and B means A intersection B, B and C means B intersection C, A and C means A intersection C, and all three means it is A intersection B intersection C. If you know this principle, then all you need to write them values here and substitute in the formula, and you'll be able to get the final answer. Okay, so I hope I made it clear. If not, please go through one more time. It will become clear. Thanks for watching this video.